here a problem. So a curve has equation of y equals 2x cubed minus 5x squared minus 3 over 2x plus 7, where x is greater than 0. Okay, of course, because if x is equal to 0, this will be undefined. Alright, so our task is to find, in simplest form, dy over dx, which means the derivative of this function with respect to x. So we'll just use the differential rules of differentiation. So let's start off with just writing the function. So we have here y is equal to 2x cubed minus 5x squared minus 3 over 2x plus 7. Okay, so by the rules of differentiation, we can just use a power rule here for this first term, 2x cubed. So the power rule will be the exponent times the coefficient, and then subtract 1 from the exponent. So we have here 3 times 2, that gives us 6x, and then subtract 1 from the exponent 3, that becomes squared. Okay, then here negative 5x squared, so again exponent times coefficient, so 2 times negative 5, that gives us negative 10, and then x raised to 2 minus 1, that's only 1, so we don't need to write that. Okay, but for this one, okay, so we have here negative, then since we have a fraction, we can use the quotient law. Okay, so if you are familiar with the quotient law, so you can go on and directly answer this in the fastest way you can. So, but for the sake of this video, we will show each step. So we will use the mnemonic for the formula of the quotient law, which is low d high minus high d low over low squared. So low meaning the denominator, high meaning the numerator. So from the formula, we have low d high. So low, that's 2x. So we have 2x times d high. D high meaning derivative of the numerator. So since the numerator is 3, the derivative of that will be 0, since the rule states that the derivative of a constant is 0. So that will be 0. Then minus, so we have low d high minus high d low. High is 3 times d low, that's derivative of the denominator. So derivative of 2x will be 2. Okay, all over low squared. That means denominator 2x quantity squared. Okay, so why did I put this inside a bracket? Because we are applying the quotient law with this term. So I just put the negative outside. Okay, so and then plus 7. So we know that the derivative of a constant is 0. So just plus 0. Okay, then we simplify this. So we can simplify this as 6x squared still, minus 10x. Then here, 2x times 0 will be 0. 3 times 2 will be 6. Okay, so we have the negative times negative, that gives us positive 6 over, this will be 4x squared. Okay, so then we can simplify this fraction. So the final form will be, so let's just make that an arrow. So y prime, or we can write this as dy over dx is equal to, so 6x squared minus 10x, and then here 6 and 4 can be simplified as 3 over 2x squared. So since 6 and 4 both are divisible by 2, so 6 divided by 2 is 3, 4 divided by 2 is 2. So then we can say that this is our answer. So this will be dy over dx in its simplest form. Okay, so next, the point P lies on the curve, the same curve here, and has x coordinate of 1/2. So that means this certain point lies on that function, okay, and the x coordinate is 1/2. So find an equation of the normal to the curve at that given point P. Writing your answer in the form ax plus by plus c equals 0, where a, b, and c are integers to be found. So we just need to find that equation of the normal line, okay, to the given curve. So the normal line, okay, to a given curve is, when we say normal, that gives us a 90-degree angle. Okay, it should be perpendicular to a certain line. So that means this normal line should be perpendicular to this curve at point P. So what line should it be perpendicular to? So that will be the tangent line to this curve. Okay, so let's say, just an example, this is not the actual graph. So let's say we have here a curve. Okay, and let's say this is point P. Okay, so the tangent line to this curve, okay, will be a line that touches point P. Okay, so that's the point of tangency. And the normal line will be a line perpendicular to that at that given point. Okay, so this is the normal line that we are looking for. Okay, so that means we will be using the derivative. Okay, so this derivative here that we have, the dy over dx, is the slope of this tangent line. Okay, and why do we need the slope? Because if we're dealing with perpendicular lines, we can use the slope of those two lines because they are slope of perpendicular lines are negative reciprocals of each other. Okay, so since the tangent line passes through point P, okay, and point P has an x coordinate of 1/2, we can get the slope of this tangent line, which is using this equation. Okay, so we just substitute 1/2 to x here in our dy over dx. Okay, so let's substitute that. That will give us y prime is equal to, so 6 times, so x will be replaced with 1/2, then quantity squared, minus 10, then x again will be replaced by 1/2, okay, plus 3 over 2 times 1/2 squared. Okay, so let's write that down bigger. So y prime is equal to, so this is 1/2 squared, that gives us 1/4 times 6, that will be 6 over 4. Okay, this 10 times 1/2 is, so let's just write it down as 10 over 2. Okay, then here we simplify this first, so 3 over 1/2 squared is 1/4 times 2, that gives us 2 over 4. Okay, then we simplify again. So 6 over 4, both of them are divisible by 2. So that gives us, so 6 divided by 2 is 3. 4 divided by 2 is 2. Then minus, so let's just keep this as 10 over 2 so that we have the same denominators. And then here, so how do we simplify complex fraction? So we get the reciprocal of the denominator and multiply it to the numerator, which gives us, so let's show that step. So 3 over 1 is the numerator times the reciprocal of 2 over 4, that will be 4 over 2. Okay, so this gives us y prime equals, so 3 over 2 minus 10 over 2 plus, this gives us 3 times 4, that's 12 over 2. Okay, so we can simplify that as, so 3 minus 10, that gives us negative 7, plus 12, that gives us, so 3 again, 3 minus 10 plus 12, that gives us positive 5 over 2. Okay, so this 5 over 2 will be the slope of this tangent line. Okay, so that means the slope of n, which is the normal line that we are looking for, will be equal to the negative reciprocal of 5 over 2. So the reciprocal of 5 over 2 is 2 over 5, and then negative. So that's negative 2 over 5. Okay, but that's not the end of it. So of course we need to solve for the equation of the line. Okay, so what equation of a line can we use? So since we have the slope, okay, and we have a point, okay, so the point here will be this x coordinate here. Okay, so that x coordinate of 1/2. Okay, so since we have this slope and the point on that line, that's 1/2, so we can solve for the y coordinate of that by substituting it to the given function. Okay, so if x is 1/2, so to make this shorter, if x is 1/2, y will be equal to 3. Okay, Okay, so how did we get this? So substitute 1/2 to the original function, to the original curve. That's 2x cubed minus 5x squared minus 3 over 2x plus 7. Then you will get y is equal to 3. Okay, so now we have this point and this slope, so we can use the point slope form of the equation of a line. That gives us, the formula is y minus y sub 1 equals m times x minus x sub 1. Okay, so here, so y sub 1 will be 3, so we have y minus 3 equals m will be negative 2 over 5 times x minus x sub 1, which will be 1/2. Okay, then we distribute this, so we get y minus 3 equals negative 2/5 x plus, so we multiply negative 2/5 times 1/2, so we can cancel the 2, so we get positive 1 over 5. Okay, and then, so just to eliminate the fractions or the denominators, we multiply 5 on both sides. So this gives us 5y minus 15 equals, so this denominator will be cancelled, we'll get negative 2x, 1/5 times 5, that will be positive 1. So just cancel the denominator. Then, since we are asked to solve it in form of ax plus by plus c, we just transpose everything on the other side. So let's just continue here. So we'll get transpose 2x, so that will be positive 2x. Okay, then plus 5y minus 15, and then transpose 1, that's negative 1, equals 0. Then we can simplify it, so we'll get 2x plus 5y minus 16 equals 0. That will be the equation of the normal line to the point, okay, to the curve at that given point, which is 1/2 and 3. All right.